In this video, I will discuss on three types of plume behaviors of smokestack occur under superadiabatic atmospheric condition, subadiabatic atmospheric condition, and neutrally stable atmospheric condition. And the plume behavior under superadiabatic, subadiabatic, and neutrally stable atmospheric conditions are called looping, coning, and fanning respectively. But at first, let us know what is unstable, stable, and neutrally stable atmosphere. We have already discussed this in my earlier videos. When ambient lapse rate is greater than dry adiabatic lapse rate, then it is called superadiabatic condition. In this graph, you can see that this is dry adiabatic lapse rate, this is moist adiabatic lapse rate, and this is ambient lapse rate when the condition is superadiabatic. In this condition, air parcel will be warmer than the surrounding air, so it will be less dense, more buoyant, and will want to keep rising. The atmosphere is absolutely unstable. In this graph, this portion is absolutely unstable. Now, if the ambient lapse rate is less than dry adiabatic lapse rate, then it is called subadiabatic. So here, this is the ambient lapse rate and it is less than the moist adiabatic lapse rate and dry adiabatic lapse rate. So in this condition, air parcel will find itself colder and denser than the surrounding air, so it wants to sink. As it moves downward, it gets warmer and less dense than its surrounding, causing buoyancy to push it back again. This atmosphere is absolutely stable and the air parcel remains in same place. So in this graph, this portion is absolutely stable, and the region between these two lines is labeled as conditional stable. Its stability depends on actual ambient temperature profile and the actual adiabatic profile. For dry atmospheric condition, when environmental lapse rate is equal to dry adiabatic lapse rate, a displaced air parcel remains at its new position without accelerating upward or returning to its original level. Such an atmosphere is said to be neutrally stable. Now, what is temperature inversion? This is also discussed in my earlier videos. Usually, ambient temperature decreases with increase in altitude. Inversion is a departure from these usual atmospheric properties. In an extreme case of subadiabatic lapse rate, ambient temperature increases with altitude. You can see that ambient temperature is increases with altitude, and this is temperature inversion. So temperature inversion represents the extreme case of atmospheric stability, and pollution tends to stay trapped here. So radiation is one of the cause of temperature inversions, and it caused by a nocturnal cooling of Earth's surface. It occurs close to the ground, mostly during clear, calm winter nights, and normally last for few hours, and it begins to form about dusk. With time, the inversion extends to higher and higher elevation, perhaps a few hundred meters. Before morning, sun warms the ground again and breaking the inversion. So this is some graphical representation. You can see at 3 p.m. it is the ambient, its temperature profile is good, and inversion found in 6 p.m. after dusk, 9 p.m. inversion, and 2 a.m. inversion occurs several hundred meters, and at the morning it, so you can find the normal temperature profile. Now, plume behavior. The behavior of plume emitted from an elevated source such as smokestack depends on degree of instability of the atmosphere and the prevailing wind turbulence. And commonly encountered plume behaviors are looping, coning, fanning, and we discussed 3 in this video, and fumigation, lofting, and trapping, and will be discussed in my next video. So first we discussed about fanning, and we discussed in a series from the morning actually. So in the early morning the winds are light and the radiation inversion extends from surface to well above the height of the smokestack. And in this stable environment there is little up and down motion, so the smoke spread horizontally rather vertically. When viewed from the above, the smoke plume resembles the shape of a fan, and for this reason it is referred to as fanning smoke plume. You can see here, so this is the temperature profile and just sun is rising. So just I put dry adiabatic lab set here, and you can see here that at this point the air parcel temperature is more than the surrounding, is less than the surrounding air, so it tends to go down. But when it's go down, its temperature is more than the ambient temperature, so it will keep up again. So the properties are occurs as a result of strong atmospheric inversion above the ground, occur in presence of calm or very light winds, surface inversion restricts downward mixing, stable atmosphere suppresses vertical mixing, however it still spread horizontally. The stable lab set cannot suppress the horizontal mixing entirely. Fanning is considered a favorable meteorological condition as plume does not contribute to ground pollution. And fanning plume is often observed at a height and in the early morning or clear nights in all seasons. So you can see this type of plume behavior on clear nights also, and this is considered as a favorable meteorological condition. So here air parcel find itself colder and denser than its surrounding, so it wants to sink down, and as it moves downward it gets warm and less dense as its surrounding, causing buoyancy force to push it back up again. Now looping. Later in the morning, the surface air warms quickly and the radiation inversion gradually disappears from the surface upward. If daytime heating on the ground conditions, the depth of atmospheric instability increases and inversion disappears completely. Atmospheric stability causes rapid upward air movement. As it rises, colder air from the above moves down to replace it. Light to moderate winds combined with large-scale thermal eddies create an upward and downward wavy pattern producing a looping smoke plume. So you can see that this is actually the afternoon, and this is the atmospheric ambient temperature profile. And if I put you know the dry adiabatic collapse rate here, you can see that this is the air parcel is warmer than the surrounding, so it tends to goes up. As it rises, cooler air from the above moves down to replace it, and a light to moderate wind combined with large scale of thermal eddies, that is rising and sinking air pockets, create an up and down wavy pattern. So this is a looping smoke plume. And properties is looping is very common type of plume behavior, occurs under strong instable atmosphere with light to moderate wind speed, occurs generally in hot summer afternoon with large scale thermal eddies are present. These eddies carry portion of plume to ground and cause high surface concentration of pollution near the stack for short period of time, and due to rapid mixing of pollutant, dilution of pollutants occur. And lastly, we discussed about coning. The continued rising of warm air and sinking of cool air can cause the thermal temperature profile to equal that of the dry adiabatic collapse rate. In this neutral atmosphere, there is no strong buoyancy force dividing the plume upward, and no inversion layer trapping it close to the ground. So vertical and horizontal motions are about equal, and the smoke from the stack tends to take on the shape of a cone, forming a coning smoke plume. You can see the shape coning, and this is a neutral air ambient and profile. I just put 3 dry adiabatic collapse rate on this. And properties occur when lapse rate is essentially neutral, that is atmosphere is neutrally stable, observed gradually in cloudy skies, clouds reduces surface heating or cooling, occurs during day and night, especially in every morning or late afternoon, especially in early morning and late afternoon. Plume spread both upward and downward at a similar rate, and the plume shape is vertically symmetrical about the plume line. So this is the center of the plume is plume line. So the plume shape is vertically symmetrical about the plume line, associated with moderate to high wind speed. Major part of the pollutant concentration is carried downward fairly far before reaching the ground level, and limited vertical mixing but not suppressed. Pollutant does not rise too high also. So for more reading, you can use these books.